aluminum foils in a rectangular form, and we have used paper as a dielectric. Now, as we can see, there is a lot of air gap in between these foils and the dielectric. So what solution we have come across is that we will place some weights, some standard weights, which we will use in all the capacitors, including this one, which we're going to measure right now. And after putting these weights, we will calculate, we will almost nullify, we cannot fully nullify the air gap, but we will almost try to nullify it so that we get a permissible value, which we can use it to calculate, so we can get a permissible value, permissible voltage drop for the known capacitor, which we can use to calculate the unknown capacitors. Hence, in the process, we are ultimately minimizing the error. As we can see, this is our circuit. We are actually stepping down the voltage through a transformer, which is connected to this main supply, and it is from the secondary side. Now we are actually attaching it through this wire. We as we can see, there is actually a parallel wire connected with a lamp and a resistor. This is nothing but a test lamp that is used to help us identify that whether there is current in the circuit. Basically, this circuit is running or not. Apart from that, now we are coming across the main circuit. From here, we are actually connecting in series the DIY capacitor or the capacitor that we made. And here are the weights so that there is no, there is a very minimal error. After that, we are actually connecting it with series with the known capacitor, or which is rated at 4.7 nanofarad, and thus which is going toward the ending of the circuit and hence closing it. 18 volts, that is the total potential of the circuit coming out from the transformer. Please show in the video. 18 volts. So for our first observation, we are actually taking the dimensions of the aluminum sheet to be 29.5 into 20 centimeter, and the area comes out to be 590 centimeters square. So we are now starting our circuit, and then we will measure the voltage drop around the known capacitor. So it is coming around 2.5 volt. Please note it down, 2.5 volt. Now for the second observation, we are taking the dimensions to be 24 into 19.5 centimeter, and the area comes out to be 468 centimeters square. So we are now measuring the potential drop around a known capacitor. So it is coming around 2 volt. Please note it down, 2 volt. It's noted. Now for the third observation, we are taking the dimensions to be 21 into 17 centimeter, and the area comes out to be 357 centimeters square. So we are now measuring the potential drop around our known capacitor. That is coming around 1.7 volts. It's 1.7 volt. Now we will take the fourth observation, and for the fourth observation, we will take the dimensions as 16.3 centimeter into 14.8 centimeter, and the area comes out to be 241.24 centimeters square. So we are now measuring the potential drop around our known capacitor, that is coming around 1.4 volts. 1.4 volts. Please note it down with the strip. Noted. So for our fifth observation, we are taking the dimensions to be 13 into 12.7 centimeter, and the area comes out to be 165.1 centimeter squares. We are now measuring our potential drop around the known capacitor for this capacitance. So it is coming around 1.1 volt.